Okay, conditional statements. Now, conditional statements you've been using your whole life. You probably just didn't know they were called conditional statements.
Are these just enough for us?
Yes. Okay. Yes, you can use them. Alright. So a conditional statement is an if-then statement. Conditional statement, actually. A conditional statement is an if-then statement. An if-then statement. Alright, so you've been using it your whole life, you probably just didn't realize it. Now we've got certain notation we can use for our if-then statements. And actually, well, we'll look at it later. Alright, so conditional statement, the if-then statement, has a hypothesis and a conclusion. It has a hypothesis and a conclusion. Hypothesis and a conclusion. Now we've got some fancy, not really that fancy, but fancy notation to kind of shorthand write our conditional statements, just to kind of help us out later. We'll do the logic tables. They're actually very interesting. And this is also, if-then statements are used in any type of computer programming. You start off with an if-then statement. All right, so notation. An if-then statement, we would write if P, then Q. Where the if part for the P is the hypothesis. And the then part for the Q is the conclusion. So if something, 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 then something, something, something. For example, if I live in Virginia, then I live in the USA. It's an if-then statement. So my hypothesis would be, I live in Virginia. Conclusion, I live in the USA. If that hypothesis is met, the conclusion is true. So if that conditional, the whole statement is true, then we know anytime when the hypothesis has been met, the conclusion can be made. Now, our shorthand notation, we can get even better than just if P then Q, is we can write P arrow Q. When we read that, we don't say P arrow Q, we say P implies Q, or if P then Q. P happens, we can immediately follow that Q will occur. Alright, now we can think of this as a Venn diagram. Going back to your elementary, middle school, elementary days. Let's go ahead and use this circle. Let's say this is all the Q's in the world. And inside of there is the category Q. Now we'll have an actual example to kind of explain what this is. But this represents what that means if P, then Q. If I have P, then isn't it automatically contained within Q? We didn't then Q. So let's take the simple example. If it is a square, then it is a rectangle. Do you agree with that statement? Right. So it's like Q is my big category of rectangles, and P is the category of squares. All squares are rectangles. So if it is a square, then it is a rectangle. So all the squares are contained within rectangles, since a square is a rectangle. Now, that statement, if it is a square, then it is a rectangle, I could change it. Instead of saying if, then I could just say squares or rectangles. But that's still an if-then statement, just kind of hidden. So that's this note here. Statements in English can be made without actually using the words if-then, but they are understood. For example, squares or rectangles. If it is a square, then it is a rectangle. So let's take a look at these 3 examples here. This middle one has that nice if-then. If it rains, then the football game will be canceled. That's that nice if-then format. But if we look at this first one, at noon, the bells will chime. There's no if-then, but it's assumed within there. How could I change this to be an if-then? How could I rewrite it? Come on.
If the time is 12, then the bells will chime.
Yeah. If it is 12, then the bells will chime. If it is 12, then the bells will chime.
Well, 24.
Alright, so it does not have to necessarily have if-then. It can be understood in English. We can use it without if-then. Now you've got to be careful. For example, 3 says, I will go shopping if I get paid today. Notice they kind of moved things around. What would be the proper way to say this in the format if-then?
If I get paid today, then I will.
Good. If I get paid today, then I will go shopping. So now it's in that nice if-then format. So you've got to be careful when you're looking at these. If it's not already in the if-then format and you struggle with maybe pulling the pieces from it, go ahead and rewrite it in that if-then format to help you out. Also, if you see that it's flip-flopped around, it's probably in your best interest to go ahead and rewrite it the proper way so that you don't pull the wrong hypothesis or conclusion. And sometimes we talk like this. Maybe your mom says to you, if you clean your room, then I will give you cookies if you clean the room. You might put it that way. Or you can watch a movie if you finish your homework. So we talk like that sometimes, or we put the if part last, so just be careful. Alright, so our first one, what is the hypothesis? Now hypothesis is a conclusion. Hypothesis is the P part, or what comes right after that if. The conclusion is the Q, or what comes right after that then. So what is my hypothesis for this first one?
12.
How about it is 12? Then what's the conclusion? If it's 12, then what happens?
Bells chime.
Yeah, the bells will chime. Alright, hypothesis, conclusion. Go ahead and write your hypothesis and conclusion for the next 2. And again, I know some of you can pull that from the statement without turning it into an if-then. That's fine. But if you struggle, go ahead and turn it to an if-then and then pull those. So go to the hypothesis and conclusion of this next 2. Alright, example 2 here. Who would like to give me the hypothesis? Go ahead, Emma.
If it rains, hypothesis, it rains.
Good.
Football game is canceled.
Good. Conclusion, football game is canceled. Do we agree with that?
Yes.
Good. Do we have questions on that? Good. Ooh, I lost my Alright. The third one. Let's do that. Go ahead on.
I get paid.
Hypothesis, I get paid.
And I will go shopping.
Okay. I will go shopping. You shop. Good. Questions about this?
So for all of them, if you kind of change, you said the bells will chime, but the football game is canceled if it rains. Does it matter if you?
You'll notice that as we were conversing versus contrapositive, you might need to change the tense to kind of make it grammatically sound. If you have the football game will be canceled, that would be fine still. Particularly when we get to the converse, sometimes you have to kind of change the wording so that when you read it in English, it makes sense the way that. But yeah, it's fine if you change a little bit. Now, if you said bells won't chime, that would be a problem because it's different. All right. Other questions on that? Okay. So that's conditional statements. Now, the key thing here. Conditional statements start off with that if-then form. So anytime we see an if-then statement, we can say, hey, that's a conditional. Now, it is helpful for us to know if the converse is true, if the inverse is true, or the contrapositive is true or false. Again, this is super helpful with computer programming, dealing with logical statements. So what are the converse, inverse, and contrapositive? Well, if I look at this example here, it says, if I get paid today, then I will go shopping. Can I necessarily assume then that if I go shopping, that means I got paid? Is that always the case? Not necessarily. And so what I just did there was the converse. I flipped the order. So I know here, if I get paid today, then I will go shopping. But do I know the other way around? And I could change this up again. If I don't get paid today, then I won't go shopping. Is that true? Or maybe I change it up even more. If I do not go shopping, then I did not get paid. So those are variations, ways we can move things around, and it's helpful for us to see if we can make those conclusions from that. So let's talk about what each of these are. First one, converse. And you've got to know which one's which, because it won't always be in this order. So converse, we switch the hypothesis and conclusion. Okay, so this is based upon my original conditional. I take that original conditional and switch the hypothesis and conclusion. Now, in our notation, instead of if P then Q, what do you think that notation would be? If Q then P. Good. Alright, so again, if we're switching the hypothesis and conclusion, then my notation is going to be Q implies P. Or if Q, then P. We switched those. So let's say with the second one, if the game is canceled, then it rained. That would be the converse. Okay, next up, the inverse. The inverse is negating the hypothesis. What does that mean to negate something?
You said like I didn't get paid and you didn't go shopping.
Good. Basically, you're throwing in that word not, going the opposite. So my inverse, we're going to negate hypothesis and conclusion. Now again, for each of these, we go back to the original. So remember, we start off with conditional, which is P implies Q. So my converse, I switch them. Now when I go to do the inverse, I go back to my original. So if I negate, ooh, we've got a new piece of notation here. This squiggle means not. It's kind of like the squiggle on top of the congruent sign, but it's just a squiggle. That squiggle means not. So my inverse notation, instead of P implies Q, would be not P implies not Q. Alright, so so we go back to that original conditional, and we throw a not in front of each of those. So let's go ahead and take a look at the first one. If it is not noon, then the bells will not chime. That would be an example of inverse. All right. Now my contrapositive. Any thoughts on what my contrapositive might be?
It's both.
It's both. Very good, Sam. So my contrapositive, I'm going to switch and negate. Or in other words, I negate the converse or I switch the inverse, right? Because it's just applying both of them. Okay? So you could write it in your fancy way. We're just going to go and write switch and negate. Switch and negate the hypothesis and conclusion. And again, we're doing this to the original conditional expression. So then here, my notation, instead of P implies Q, it would be not Q implies not P. All right, so we switched them and negated them. So these are the different variations. We've got conditional, P implies Q. Then I can switch that order. If and then stay in the same place, but we switched the statement hypothesis and conclusion. So switch gives me converse, negate gives me inverse, both gives me contrapositive. And you've got to remember which one's which, because I could ask you on a test for the inverse first, or maybe the contrapositive first. You need to know which one's which. All right, so let's take a look at our first example here. If you are a student, then you have lots of homework. It's a true statement. Well, maybe not those kindergartners, but in high school, you have a lot of homework. All right, so let's go ahead and identify what would be my hypothesis for this.
You are a student.
You are a student. So here's the P part. And what would my conclusion be? Alright, so I want you to go ahead and try to write the converse, the inverse, and the contrapositive. So again, converse, switch, inverse, negate, contrapositive, both. Once you get your answers, go ahead and compare with someone nearby you.
hypothesis line contains if you are not a student, then you do not have lots of homework. If you do not have lots of homework, you are not a student.
All right, let's go ahead and go over these together. Converse, go ahead and tell me what you got.
If you have lots of homework, you're a student.
Good. If you have lots of homework, then you are a student. Inverse. Did we get if you are not a student, then you do not have lots of homework? And contrapositive. If you do not have lots of homework, then you are not a student. Questions on those? So again, we can take any conditional, and from there write its converse, write its inverse, write its contrapositive. Now, here comes the key part. Just because the conditional is true does not necessarily mean the converse will be true. Or just because the conditional is false doesn't necessarily mean that the inverse will be false. So this is huge down here. Put a big star next to it, highlight it, do something to make this stand out to you. But we're going to talk about their truth values. Their truth values. Meaning, is the statement true or is it false? When the original statement, your conditional, is true, then the contrapositive will also be true. So when your conditional is true, your contrapositive is true. Likewise, when the original, the conditional is false, the contrapositive is false. They're either going to both be true or both be false. We say that they have the same truth value. Same truth value. By truth value, we mean either it's true or false. Okay? So conditional and contrapositive go together in that regard. Now, interestingly, the converse and inverse work together that way as well. The converse and inverse are either both true or both false. So if the converse is true, the inverse is true. If the inverse is false, the converse is false. So they have the same truth value as well. So the same truth value. Okay? Now, these might be different from your conditional. They might be the same, but it might have a different truth value from the conditional. Okay? So conditional, contrapositive go together in truth values. Converse and inverse go together in truth values. Let's kind of take a look at this with one simple example. All right, let's take the statement, my original conditional. If I live in Virginia, then I live in the USA. Is my conditional statement there true?
Yes.
Yes. If I live in Virginia, it follows that I live in the USA. All right. Now, what is my converse going to be?
If I live in the U.S., I live in Virginia.
Good. If I live in the USA, then I live in Virginia. Is that true?
No.
No, not necessarily. Why not?
You could live in Wyoming.
Yeah, you could live in Wyoming, so you could be in the USA and be in one of the other 49 states. All right, now our inverse we should expect to be false. Since the converse is false, our inverse should be false. Let's take a look at it. My inverse. If I don't live in Virginia, then I don't live in the USA. Is that false? Yeah. If I don't live in Virginia, again, I could live in one of the other 49 states and still be in the USA. So that would be false. Now let's take a look at that contrapositive. squeezing it in here. If I don't live in the USA, then I don't live in Virginia. What is that? True. If I don't live in the USA, I can't live in the state of Virginia, because the state of Virginia is in the USA. It's contained within there. So that would be true. Notice again, conditional and contra have the same converse and inverse. Some questions on that? Okay. Now let's take a look at biconditionals. Go ahead and flip that page. Our last thing. Biconditional statements. Now this first part is again just summarizing that notation that we talked about on the front side. P implies Q. If P then Q, it's a conditional statement. P is the hypothesis, Q is the conclusion. And this little squiggle means not. Okay, so that first part is just summarizing those notations together. P and Q are symbols used in logic tables. Again, logic tables is something we'll do later. And so this here is just having you practice writing out your converse, inverse, contrapositive using that notation. So let's take a look at this one. If my starting statement is not P implies Q, my converse, where we switch, would be Q implies not P. My inverse, which is just negating my conditional, would be P implies not Q. Right? I just did the opposite here. Not P means just P. And not Q. What would my contrapositive notation be? Good. Not Q implies P. So that's just practicing that notation that we talked about. But now let's talk about what a biconditional statement is. This is just one additional thing. You'll notice it has the word conditional in it. And biconditional, think bicycle has two wheels. Biconditional goes two ways. It goes both ways. So it is an if and only if statement. Your biconditional has a statement, then the words if and only if, then another statement. It's kind of like having your hypothesis, if and only if, conclusion. Except, since it works both ways, you could have your hypothesis and conclusion in either place, because they are both the conclusion of the other, the hypothesis of the other. So it's true both ways. So in order for us to be able to write a true biconditional, or to write a biconditional, the conditional, the original if-then, P implies Q, has to be true, as well as the converse, the other way, Q implies P, have to be true. Okay? So we can combine that together and say P implies Q, Q implies P, or P if and only if Q. So this is my notation for that biconditional. It's that little double arrow. When I write it in class, you'll see it written like that. Okay, it's like double arrow going in both directions. So your mom might say to you, you can go to the mall if and only if you clean your room. What this means is, if you clean your room, then you can go to the mall. Or if you're able to go to the mall, then that means you cleaned your room. Okay? So it goes both ways. So again, the symbol for a biconditional is that double arrow in both directions. And this means that either P or Q could be your hypothesis. Alright, so real quick then, let's just take a look at this example. Starting off with my statement, if x equal to 3, then x squared equals 9. Can I write this as a biconditional? Can I go both ways with it? Why not?
Because it has a then.
Not just because it has a then.
Because the then part says x squared equals 9, and a biconditional statement can go both ways. And when you solve the second one, there can be two answers, so it can't only be positive.
Good. If we go this way, if x equals 3, then x squared equals 9. That's true. 3 squared is 9. But if I try to go the other way, if x squared equals 9, then x equals 3. No, x equals both positive and negative. So this we couldn't write as a biconditional. But if we changed it to say plus or minus 3, then we can write as a biconditional. So remember, next class, you have your, you have your test. No, this is not on it. It's just going to be over Unit 1.